Yeah, welcome everyone. The subject I want to talk about is creating cinematic content in Unreal efficiently and the various processes that can enable this. So firstly, I'd like to introduce myself. I know Brian just said this, but it was on the slide already, so I'll just do it anyway. My name is Richard Boisvert. I'm a senior cinematic artist. I have over 10 years of experience working in the games industry, where I worked in various capacities as either a content creator, helping design tools and systems, and documentation. Currently, I'm working for Dreambeast Media, where we offer Unreal Engine cinematic services such as integration, workflow consultation, and system creation. In terms of the products I've shipped, I have credits on Dragon Age 2, Mass Effect 3, Dragon Age Inquisition, the Frostbite engine, where I assisted the cinematic tool team as a test content creator, and Epic Games, where I wrote documentation for Sequencer. Most recently, I also released a feature-length film made in Unreal Engine called Torn Seas. This was largely a personal solo film project made over the last few years, using many of the techniques and workflows that I'd like to talk about today. So before starting, let's take a look at a short clip from Torn Seas. Once again, I'd like to emphasize that this was a solo project. I only hired outside help for 3D modeling and other miscellaneous things. So please feel free to form your own impression or temper your expectations, or maybe a bit of both.
Thanks.
What happened down there?
One of the Novas connected to me and tried to take control.
Novas can do that?
They're not supposed to. I had no choice.
How do you feel?
More lonely. All I ever wanted was to fight for change. Real change. But now all I want is to go home.
You know, leaving your people and coming to save us was the most Nova thing you could have done. They always say they stand up for what they believe in. They just never thought it would be against them.
Yeah, so lastly, for this introduction, I want to outline the goals for this talk. I want to bring awareness to what I think is a realistic and achievable form of in-engine cinematic content creation. We'll talk about how this has been achieved in the industry already, past and present. And I'm going to try my best not to assume too much about what your Unreal understanding is, so my apologies if I'm covering things that seem second nature to any of you. I want to teach alternative approaches to using Sequencer. So to me, Sequencer is more than just a drop point for animations you might have exported from Maya. It also doesn't have to be a black box for artists to send requests to engineering to tool things in, things that may already be possible with a bit of blueprint knowledge. I want to increase your confidence in creating and editing blueprints from a cinematic perspective. So it does require a bit of lightweight blueprint work, and which may be daunting, but if we do that, then it can enable incredible in-engine workflows. I want to look at how you can make your blueprints more cinematic and sequencer friendly. Out of the box, blueprints may not be easy to understand, especially from a cinematic perspective. So let's demystify some of that stuff a bit. And then I want to provide concepts and examples. There'll be some tutorials in this presentation, and I want to demonstrate how today you can create some of these systems. Okay, so the motivation and why this approach, what are the benefits of in-engine cinematic content creation? Well, first, it does allow you to build content directly in engine, and hopefully this reason speaks for itself, but if not, there's massive benefits for working in the engine. It reduces or eliminates tedious round-trip workflows between external tools and Unreal Engine. And hopefully that means that there's only one source of truth for a scene. There's no play blasts or storyboard edit to kind of compete with the Unreal edit and confuse people over what the correct edit is. It also allows you to work with the latest or the final art in a level, giving you more control and understanding over your cinematic composition. In other words, it kind of allows for location scouting in the level itself, which is quite nice. It's a springboard for cinematic content creation, so scenes can be made quickly. You can build up a library of quality controlled animations. Scenes can be pre-visualized quickly and then built up over time in several passes. So put another way, it expands the range of how cinematic content can be made. It could allow something like a lead to previs a scene within the engine and hand off to the team, as an example. It bypasses currently tedious workflows and instead uses a proven workflow. Proven workflows like non-linear editing, like using animation clips, blending, layering, creating shots and sequences. This is all stuff that works today in Unreal Engine, and it works well. It avoids the difficult and unproven workflows like animating in engine with control rig and using Unreal's outdated and non-animator friendly manipulator, or the Gizmo tool as it's sometimes called. And you can leverage additional systems built in blueprints and animation blueprints. So you can solve animation problems easily with blueprints such as ticking values, IK, virtual bones, and other features. And then you can plus up your actors and cameras with systems to automate behavior, like something like an auto-focusing camera comes to mind. And so this is not a new concept for the industry. There's numerous examples of games or studios that have done this approach for their games. And most of this was a need-based approach, as games like these have cinematics that feature branching and dynamic characters and other variabilities that require some kind of in-engine content creation tool to manage this. However, what I want to do here is for us to strip out the systemic and the variable needs for tools like this and just analyze the content creation aspect of these tools and what they kind of generally offer. And that is a tool to pose or animate a character on a timeline. You have layers for acting and auxiliary systems that handle things like head look, IK, and other miscellaneous things. And then before continuing, I would like to speak to the common and I think valid criticism that cinematic content from these sources does receive. And in general, it seems that the common themes of this criticism is around quality, bugs, and glitches. And now I don't mean to excuse the content and make excuses for this, but I do want to provide an explanation over why I believe this happens as someone who's worked on some of these projects. So to me, one of the reasons is there's a lack of artist-driven tools. And what I mean by that is it would lead to a sort of a black box delivery from engineers, miscommunication over needs and feedback, and generally a slow feedback loop. So what I mean by that is, an example might be an engineer comes to you and says, okay, cinematics team, here's your head look system, but it only interpolates linearly. It doesn't support camera cuts. You can't instant on and off it, or you can't snap to a target. It doesn't blend. Let us know how you like it, and we'll adjust the system in about 3 months. And so that's like a terrible feedback loop, and the decision and cost feedback loop is broken, meaning that the people who are making the decisions of how something should be implemented like this are not the same people paying the cost of using it. So this gets kind of thrown over the fence both ways. It leads to a lack of understanding of capabilities and the pitfalls of these tools by the artists. So you get this tool, you don't know what you're doing with it, and you make some bad content with it. The bad content leads to bugs and glitches. And it's just kind of a vicious cycle. So I believe this is solvable by the team owning its own process. You don't need to be throwing requests like this over the fence. A lot of this stuff is solvable today within the team, and we're going to take a look at what some of those solutions could be today. The next is out of control scope. And this largely comes from the branching cinematics and the massive line count that some of these games can have. And that leads to also like lots of high cost, low impact variations, meaning a lot of them are just branching for branching's sake, and that leads to like an imperceivable quality from the audience or the player. Like if you can't notice the branching's happening, then it didn't seem like the cost was worth paying at that point. And so to me, I think the goal should be to ensure that any kind of variability is perceivable as much as possible. Then the value is there, and then the cost was justified. And then next is film or animation skill sets on the team. And so not everyone on the team may have the appropriate skills to tackle every single scene. Some are good animators, but terrible filmmakers. Others are great at camera work, but have a terrible eye for animation quality. And so you should adjust your team accordingly to what strengths are required. Ideally, it's a mix of animation and cinematics are needed for such a thing. And lastly, it's bad or unpolished looking animation. So sometimes some animations being used, they're just bad. There was a poorly cleaned up piece of mocap, or poorly hand keyed, or it just wasn't polished enough. And there's so many jerky looking animations in some of these examples. And I just think this is solvable too by better quality control on what animations are provided and used. If you're going to be building some kind of library with these animations, do not fill it with junk animations. So this is all to say that I think this is solvable. And the games here, we're just kind of working under these unfortunate constraints, and that's what leads to issues like this. Okay, so let's talk about the animation library. And to me, it's a different but a familiar approach for generating cinematic content. So how is it different? Instead of bespoke made for shot animations like you see in traditional cinematic animation, it's a library of reusable animations. You use this library to assemble your scene, find clips and animations that work best. You lay down these tracks and you fill in your content that way. We're talking about animations like poses, idles, enters, exits, transitions, locomotion, and additives. There is an upfront investment to the library, but long-term benefits as the library grows. As you fill it up, then there's less of a need to get all these different walk cycles. Ideally, you've got them all. And the cost lessens as the library grows. But at the same time, there's also room to expand into things like creatures or monsters or other non-humanoid entities. So it's different, and then it's familiar. And how is it familiar? It is somewhat similar to gameplay animations in a way by splitting these up into poses and transitions. Gameplay animations do have idles and transitions and poses and states. But the difference is that this is higher fidelity animation. We're talking about smooth, seamless animations that don't even appear like reusable clips. We're talking about longer lengths, longer blends, and more settle time. We're not talking about a short 20 frame run cycle for gameplay, but we're talking about a 300 plus frame of a character running, slowing down, and coming to a well animated stop to an idle pose. So let's take a look at what kind of animations would make up a library. To me, there's three types of animations that go into making a robust library. The first one is base animations. These are animations that provide a base pose or a performance layer. So this would be useful for blocking out how you may want a character to move or generally behave in a shot. It's used for putting your character into their initial poses and good for starting your camera work and framing and that kind of thing. And it's also used to locomote and move your character around. Is your character entering the shot? Is he leaving the shot? Is he pacing around? And it's high reuse, meaning that you can consider these your foundational animations meant for a high amount of reuse, and there's massive library growth potential for all the different poses you can think of: sitting, standing, leaning, picking up objects, etc. So there's lots of growth here. Next, we have additive animations, and these ones are animations that play on top or additively to the base layer. And specifically, that means that these animations are set to be additive in their animation sequence asset. And specifically, the setting is that they should be set to local space additive and then frame from this animation and then set frame index to 0. What that does is it makes it possible for these additive animations to be additive to any base pose. So they're very versatile. They're not just linked to the standing default pose. This is your acting or gesturing layer. So these are targeted animations, typically only affecting a specific limb like arms or the head, looking and gesturing and stuff like that. And it contains animations like hand gestures, head nods, weight shifting, stuff like that. And again, they're high reuse, but they're meant to be used appropriately, as some additives may not work well with all poses. So it requires a bit of animation discretion, and that becomes important. And both additives and base layers, these are like your bread and butter. There should be lots of layering and cross use here, and ideally the majority of your scenes could be made with a system like that. And lastly, we have custom animations. And they are similar to base animations in that they play at the base level singularly, but they may not be for blending or mixing with additive layers. They're meant for performances that the base library cannot achieve. The base library is about setting out like just generic acting sort of animations. These are like special moments. And these are kind of a higher cost fallback if a scene requires a special moment. So in this way, custom is somewhat similar to traditional cinematic animation. It's a unique moment, but ideally it's happening at a fraction of the cost, as these moments may only be needed for a portion of the scene or even a single shot. So an example of a custom animation is something like a special interaction between two characters. They're hugging, like a fight, some kind of stunt maybe, or any kind of like money shot that the base library can't provide. And the expectation is that these are one-off animations and they may not be reusable due to their specific nature, but you never know. There may be times when they could be reused, and that's great. So much the better. Okay, so let's take a look at a short scene from Torn Seas and break down how this library was used.
Are they treating you well? Where are your chains? Huh? Your chains! You are their prisoner, aren't you? Why else would you be there?
I'm here under my own free will.
Coward! Traitor! Now! Isn't that interesting?
Okay. So for shot one, I'm doing the following. Most characters are playing a standing idle base animation with some weight shifts. For the speaker, he's playing a transition animation from standing idle to a hands behind back pose and then continues playing the hands behind back idle. So that affects his base pose only. And then on top of that, I'm also layering a weighted down look left animation to have him give a sort of look to the guy he's speaking to. And then I'm also affecting his eyes as well to keep him looking. For shot two, the character is in the standing idle base pose again, and then a head tilt additive animation is layered on top. For shot three, the following is happening. The character is playing a weight shift base animation. Then he plays a two-handed sort of shrug animation on top. Then he additively looks over his shoulder to the left, thinks someone over his shoulder. And then lastly, he plays a gesture forward additive animation. So a lot of layering going on. This is your acting going on. For shot four, I'm simultaneously layering a yelling additive with a hand gesture additive. So just to speed things up, I'll stop mentioning the base animation layer. In most cases, we can assume it's there's everyone standing in the standing idle pose. So for shot five, I'm doing the following. This guy is playing a dismissive additive animation. This guy is playing the yelling additive animation again. And this guy is playing a weight shift. And lastly, for shot six, we're using a point up animation additive and then layering with it another head look down additive animation. So with such a short scene, you can already see there's a good amount of animation reuse going on. And the great thing about this reuse is that to me, I think it's mostly imperceptible, meaning it's not coming across as blatant. It's a blatant reuse. The context and the scene's always shifting. The acting and the camera angles are different. And so it really does a good job at hiding that this stuff is being reused, and it just increases the quality by that amount. Okay, so before continuing off the animation library, I want to say last few items of note about it. And the first thing I want to talk about is I want to bring awareness to a common pitfall for most of these library animations, which is ensuring that you're including the appropriate amount of settle or padding time. That makes sense? Usually for when an animation ends, but sometimes at the beginning. And so the idea about behind this being is that when a clip ends, it's typically blending off if it's an additive, or blending to a pose if it's a base animation. And too often I see these settle frames are not included, which causes very obvious looking blends. And so to me, including this data goes a long way in making sure your transitions and additive animations look seamless and natural. And this is one of the main reasons why these clips differ from gameplay animations. Because they're cinematic, we don't need to worry too much about making the ends of these fast and blend quick. Instead, feel free to include as much settle time as reasonable. Most of this mocap data is there, you just got to include it. So just to make it clear what I'm talking about, on the right side animation, you can see him very obviously blending into the standing idle pose when the weight shift animation ends. So it looks like he's just hitting a wall. And I see this a lot in the games that attempt this system, and it's just very obvious looking, and it decreases the quality in my mind. So the left side has that settle data, and you can barely tell that it's blending at all. And secondly is root motion usage. And I personally recommend that all library clips should not contain root motion, even the ones where the character is moving around. And so what this means is that you will have to structure your locomotion animations as either enters or exits. An enter animation is where a character starts off route and then walks from a cardinal direction and ends on his route, likely in a standing idle pose. And then an exit animation is the inverse, where the character starts en route, likely in the standing idle pose, and then walks in a cardinal direction off route. And this should be the case for walks, runs, turns, anything where the character is being redirected, any kind of locomotion thing where there's a start and stop point that is off route. And so I make this recommendation because route motion is still not very well supported in Sequencer, I find, especially when constructing cinematic content in this way. Ideally, I think we all would like it if Sequencer could translate the character around similar to how story mode in Motion Builder does it, but so far it doesn't really work that way. And then there's like little gotchas and caveats that make it not a fun experience. Okay, so if we're not using route motion, then the trade-off we have to deal with now is it does make it somewhat easier to manage your clips. There's no need to worry about transforming your character around. It's all in the clip, so he'll just walk around as needed. But now you must manage what clips you're using. Is it an enter? Is it an exit? And then take appropriate steps if your character is starting or ending off route. Because if it's an exit and when that animation ends, you're just going to pop right back to the route location. So this requires camera tricks and cuts and teleporting the character around. Or it could be mitigated with extra padding after these animations end if you want to hold the character in place. Okay, so let's move on and talk about animation blueprints and specifically how you can build or edit one that's nice and digestible for cinematic animation. And the main change this is going to cause is that your character will no longer use Sequencer's default custom mode, but instead uses an animation blueprint directly. And for those who don't know, custom mode is essentially Sequencer's own animation blueprint that gets enabled when a character doesn't have an animation blueprint assigned to him. So it's possible you may have been using this already without even knowing it. And so when working on game projects where there's shared blueprint logic, it could mean that you have to make a cinematic animation blueprint subgraph evaluating somewhere near the end of the anim graph, which bypasses the gameplay logic. And however complicated the cinematic blueprint ends up being, the goal should always be to ensure that it provides as few steps as possible for the cinematic content creation process. So things should be as automatic as possible, and ideally they should, just work. Okay, so what does this mean in practice? Well, it could mean one of two things. If you're working on a cinematic only project and it's just as simple as creating an animation blueprint and assigning it to your character, then you're done. Since this is a cinematic only project, you can own and make that blueprint in anything you want. But if you're working on a game where the animation blueprint is shared, if it's on the player or something, then it might be best to create your animation blueprint and then reference it in the main gameplay animation blueprint graph somewhere near the end of the anim graph. This can be considered your cinematic layer that plays. This requires a bit more care, as you have to ensure that any system you build here is not disrupting what's coming before it, like the entire gameplay system. So you have to be mindful and collaborate with your technical animation team. But if it all goes well, this is basically just your ticket to just have your animations work, and that's your layer that you can work in and build your systems. Okay, so regardless of how the animation blueprint is set up, one of the first things you will need to do is create slots. Slots are entry points within the anim graph where animation can be injected into, which Sequencer does when playing animation on characters. So with your character now assigned this new animation blueprint, you may notice that animation is not working on him anymore when playing in Sequencer, and that's because there's no slots assigned to the character or in use in the anim graph. So to resolve this, in the top image here, just add a slot node targeting the default slot in anim graph and connect it. And what that does is it essentially produces the same animation behavior as Sequencer's custom mode. However, if you're working on a game project where animation blueprint logic is shared, it is very likely that default slot is reserved and being used for gameplay systems. I've seen this many times before. And so default slot can't be used. It's being used by gameplay. So you may have to create a new slot for cinematic purposes only. But when you create a new slot name to use, you have to be mindful now that the default slot name that sequencer targets animation to must also match the new slot name. By default, it's always going to point to default slot. So it's going to be annoying to always type in a new slot every time you reference an animation in sequencers. Therefore, ask an engineer to look into changing the code for you. And it's very easy to do. The code's located in movie scene skeletal animation section.cpp. You just change the slot name property that's highlighted at the bottom there to the new default slot name of your choice. And it's very safe and easy to do. This only affects the default slot name usage in sequencer. So this is what I recommend doing. If default slot is taken, you find a new slot to use as your default. Okay, so let's talk about arranging the slots for a library use. So now to utilize both base and additive layers of your animation library, you should create what I recommend is a base arrangement of one base layer slot and about 3 or so additive layer slots. The additive layer slots must be connected to the apply additive node to ensure the injected animation is correctly interpreted as an additive. And each slot name must be unique to ensure that they stack on top of each other correctly. So in this example, I've named each additive layer add 1, add 2, add 3. They're different. And then the base layer I've called CineBase. And this is all the logic you need to start using your library animations. So now you can go into sequencer and at the bottom image do the following. If it's a base animation, then you just add it normally as an animation track, just like you would today, and it should just play. If it's an additive, then you have to add a new, you would add another animation section and then right click it and then set the slot name to one of the additive slots you've created. And you can do this up to 3 times. You can have 3 layers deep of additives playing. And this is how you can build your performance in sequencer. So this is pretty cool stuff. What else can we do? Well, we can use blend masks. Blend masks are great because they provide a really easy way to include or exclude bones from playing animations. So gameplay systems typically use this to play upper body animations, like in shooters where a character is playing a reload animation and you can play it either when he's stationary or when he's on the move. But now that we're driving cinematic animation logic through anim blueprints, we can start using systems like this too. So earlier, we saw that there's a hands behind back pose, and it would be really nice if we could combine that pose with some of the other animations we have, like walking. And rather than going out into Maya or wherever else and creating a new animation, we can use blend masks to do this instead. So this means we'll be creating an arms only blend mask and then a slot to correspond with it. So first, create the blend mask in the skeleton asset, and then set all the bone influences to 0 and set only the arm bones up to 1. Next, go to your animation blueprint and create an arms only slot and connect it to your preceding layer logic to a layered blend per bone node. On this node, you set it to use the blend mask and then point it to your arms only blend mask. And so one thing to note is that right here are these cached pose nodes, and pose caching is the only way in an anim graph to split anim graph poses into multiple sources, similar to how you might have a single pin connected to multiple things in blueprints. So we need to do this here. Otherwise, the arms only behavior would be constantly running, even though an animation is not being used on that slot, meaning the arms would be dead unless we're informing the slot with a pose, the same pose that the base pose is receiving. But once this is done, you can now target animations in sequencer to arms only, and they should only play on the arms. This is great because using blend masks in this way makes your library far more versatile. It doesn't require really any new cost of any new animations to be created. And so this is pretty cool stuff. So what else can we do? Well, we can start creating some automatic IK systems. And why would we want to do that? IK can be used to pin hands or to world or body locations that require certain poses. That poses require that contact. Pinning is required so that additive animations can be layered on top without swimming. We'll talk about what that means later. And pinning can be automated in the animation sequence and the animation blueprint itself using anim curves. So as an example, we have a table lean pose, and if we play one of our additive library animations on it, we see that the hands are affected by the animation. They're swimming, as it's sometimes called. And so someone might say, well, we could just make a blend mask for this like we did before. What about like a head only blend mask? And that way it neutralizes all the body animation, and wouldn't that fix it? And yes, it would, but we would also lose all the nice secondary motion in the body and pelvis. And that's, to me, that's not a worthy trade-off in my mind. So let's try to find a way to pin the hands and see if we can do it without adding any extra steps to the content creation process in Sequencer. Okay, so the first step is to create some virtual bones. So virtual bones are bones that are parented to a bone, but then follow another bone, like if they were parent constrained. We can use them to act as our IK effector location, operating in the desired parented bone space. Because the desired space in our example is the location in the world, it's a table, then the parent space should be the root. If it was something else, like if the hands were on the legs, then we want the base space to be pinned to the legs instead of the root. So in this example, I've created a couple of virtual bones on the skeletal mesh. You can see they are parented to the root bone or reference bone in this image, but following each of the hand bones, just as if they were parent constrained in Maya. I've also created a new blend mask and set only those virtual bones' influences to 0, and you'll see why I did that in a moment. Next, we'll add some anim curves to the table lean animation sequences. So anim curves are attributes that are synchronized to the playback of an animation sequence. Their values can be keyframed and adjusted over time, and we can use them to specify when something happens, like when the IK pinning enables and disables. So what this means is that in each of the table lean animations, the idle, the intro, and the outro will create an animation curve, animate it from 0 to 1. So in this is the table lean transition. So it's blending from 0 to 1. A value of 0 will mean that IK is off, and then a value of 1 will mean the IK will be on, and we can blend this nicely. And we only need to do this on the animations where IK is being considered, because the way the anim curves work is that if they're not in use, it will assume a value of 0. So that's great. We don't have to go through any other library animations and add a whole bunch of curves to them. It's just gonna work, hopefully. And lastly, we'll return to the animation blueprint and set up our IK logic with the virtual bones and the anim curves we've just created. So in this example, I've created a couple of simple 2-bone IK nodes, each targeting the left and right hands. And my apologies for not including a screenshot of how these are configured, but just let me explain essentially what these are doing. Each one is targeting either the left or right hand bone, as you can see. The effector target is the corresponding virtual bone for the hand. And the joint target there is just the pull vector space pointing the elbows backwards. And then I use the value of the anim curve. You can see left hand IK and right hand IK. Then I use the value of the anim curve to control the alpha value of this node. So the anim curve will drive whether or not the IK will run. Next, I've modified the additive layering logic to now go through a layered blend per bone node, which uses that no virtual bone blend mask. So this all seems very complicated, but what this is essentially doing is it's leaving the virtual bone, the IK effector, alone in these additives. It's leaving them alone. It's letting only the base animation affect the effector's position. Additive animations will now not affect its position, essentially pinning it in place, but only for animations that tell it to do so with those anim curve values. So now if we go back to Sequencer and play that animation, we see the hands are pinned in place. And the wonderful thing about this is that there's no extra steps needed in Sequencer. All this behavior is happening automatically with the animation blueprint and the anim sequences. You don't have to add a track that turns the IK on or anything like that. It keeps your sequencer nice and clean. It's all happening within the animation sequence. The animation is the thing that's providing the logic and the context. It's wonderful. Okay, so these are just a few examples of how animation blueprint usage can enable smart and automatic behavior for cinematics, and that's the goal I want to emphasize. What I mean by that is that, ease of use is the goal regardless of what system gets implemented. So with the IK example that we just looked at, it's possible that using virtual bones and blend masks and that whole system I set up was like the wrong approach. And if there's a better and more performant system, then by all means use that instead. But the goal should be the same, that these systems require as few steps as possible in the content creation process. If you're adding new tracks, New tracks are fine, but you have to keep that under check, I think. And the final thing to note is that all this was done without leaving Unreal. I didn't have to go to Maya and make some IK bones and animate them a certain way. Unreal provided all the tools that were necessary for this. It's wonderful. Okay, so we covered some of the things you can do in your animation blueprint to make it cinematic or sequencer friendly, but now let's look at doing the same thing, but for normal blueprints. And so rather than animate skeletal meshes or static meshes directly, I would consider making blueprints of them instead. Like animation blueprints, it's possible to create functions and behaviors in these blueprints to assist cinematic content creation. And this is something you can do for anything, for your characters, your cameras, or even lights, all the things that kind of go into making a scene. Before looking at some examples, I do want to cover some important points about ticking. So some of you may have heard about ticking in Unreal Engine, but for those who haven't, ticking usually means when a function or script is executed either in code or in blueprints. It's easy enough to make a new variable in blueprints and then expose it to cinematics, but more steps are needed to make it tick. And then how do you do that? And so one of the ways that possibly you might have heard is there's something called run construction script and sequencer. However, it's a very dirty way of achieving this, and Epic doesn't recommend it, and it causes lots of badness, and I typically stay away from it. You could also connect your variable logic to an event tick, which will correctly execute the logic at runtime, but it won't preview an editor. So it's something that only works when you're playing the game instead of seeing in the editor, and that's not good either. Whatever the solution is, remember the goal for sequencer-friendly blueprints is to have them tick both in editor and at runtime. It is possible to set up your variables in a way where they execute their logic in the construction script, then animate in sequencer, both in editor and runtime, and only tick in isolation when sequencer plays. So you can see in the images here, I'm exposing a blueprint variable to sequencer where you can add it as a track, but then now what? What logic can you make to make this track do something? And another thing to be mindful of is related to ticking is that while normal blueprints do not continuously tick in editor, animation blueprints do. So this means that you can access exposed variables within the animation blueprint and then animate them in sequencer, as I'm doing in the middle image there. However, it's somewhat tedious as you need to add lots of shell tracks to kind of get to the variables. So in the middle image there, you can see I had to add a skeletal mesh component, then the anim instance track, and then finally get my variable. And it will animate, but it's kind of unfortunate you have to drill so far down to kind of bloat your sequence track use in that way. But blueprint interfaces are a solution that provides a sort of one track solution for driving animation blueprint behavior from a blueprint. So instead of adding all those shell tracks, you can add one, and blueprint interfaces provide a solution to achieve this. So let's dig into some examples now. And I must apologize ahead of time, but I may not have time to cover all the precise settings and steps for these examples, but I still wanted to at least cover the general approach of what I took and provide you kind of a signpost of what I did and what the results were. So the first example is a basic look at system where the goal is to have the eyes of a character track any kind of spatial target in a level. And so what we're going to do is we're going to use an aim offset asset that outputs the data for the looking. So in this case, the prerequisite is that you have an aim offset already created with single frame eye poses, as you can see in the top image there. Next, you'll create a blueprint interface asset, and inside it, create a function for passing a vector from one blueprint to another. Essentially, this means in your blueprint interface, you create a function with a vector output, and it should look something like the middle image there. And lastly, you would go into both of your blueprints, your character blueprint and your face animation blueprint, and implement the blueprint interface to make them able to communicate. So you implement the interface in both blueprints, that makes them communicate, and that kind of forms the connection. So now that the blueprint interface is implemented in the character blueprint, you can open it in the sidebar and build logic to output the vector. So in the top image, example, I'm using the location of a target point in the blueprint to drive the look at position. It could be anything, but in this case, I'm just using a target point that's part of the character. Next, you open the animation blueprint and create that logic that receives the information from the other blueprint. So in the middle image, So in the top image, rather, I'm sending the transform, and then in the middle image, I'm receiving it in the AnimBP. I'm getting the owning actor from the character blueprint, and then getting the data from the blueprint interface. And then this logic is built in a pure function so that I can use it in the anim graph. And then lastly, I just connect that information to the look at aim offset. And now this results with you being able to animate this look at target around in Unreal Engine, and your character's eyes will follow it. You may have to add an animation playing on your character in Sequencer, as anim blueprints don't tick until there's an animation to play. But this is great because you can look into making the system even easier to use by making logic for the look at to snap to targets and exposing that as a track in Sequencer. So you can easily make it so that you specify another character and that target will snap to the eyes, and then therefore the character would look at the other character. It's really fantastic. Okay, so for this next example, let's look at setting up a camera that can autofocus. And before continuing, I am aware that the cinematic camera already has automatic tracking built into it. However, I find it's a bit limited, mainly that it can only track the root location of an actor and not a specific socket or bone. So it would always be like looking at the character's feet, for example, and not at a bone in the head or maybe a socket that's in the forehead or something. So that would obviously be much more useful when auto tracking a character or some other creature. So let's see if we can improve this system using blueprints. And utilize an interesting behavior involving camera components. So I've said before that building logic off of event tick isn't really desirable, because event tick is only for runtime and they do not preview an editor, only runtime. There is only one place that I'm aware of where this is not true, and that's for components added to camera classes. So that top image there where you see it executing on event tick, that is not happening at runtime or in a simulation. That's happening in editor. I'm not playing the game. That is a component added to a cinematic camera, and cinematic cameras appear to tick their components when they're connected to event tick. So this is great because for these components, the event tick logic will execute both in editor at runtime, which means we can just build our logic there, and then it should just work. So to start, we'll create these two assets. We'll create a child class of the cinematic camera and a new actor component. And the actor component is going to kind of contain a lot of our logic. So the first thing you want to do is we'll go back to the blueprint interfaces. You want to implement the blueprint interface just like we did before in both the camera and the component, form the connection between the two. And that's good. Next, you'll want to add two functions to the interface. You want to add one for sending the actor information. So ideally you want to specify an actor as a track, and then that will get interpreted by the component, all the calculations and stuff, and then it will send back out the final focus value. So there's two functions, one for sending actor data and one for sending focus information, which is just a float. And now this next part might be a bit complicated because there's several steps, but the essentials are this. First is you create your actor variable in the camera blueprint, and then connect it to the blueprint interface's actor output for sending to the component. So the actor is now being sent to the component. Now in the component, you create logic off of event tick that reads the actor from the blueprint interface, and then you make your calculations. So in this case, the function that I have there, it's basically checking, did you find a skeletal mesh? If so, then find the location of the head bone, and then get the distance between the camera and the head bone. Then that outputs a final output as a message to the BPI function you made. So that's that set focus message at the end there. Now back to the camera blueprint event graph. Now we've got that event set focus that's receiving that message. And it creates logic, and then you can create logic for setting the actual focus distance on the camera itself. And even though there's logic in the camera blueprint, because the component will tick, the event will receive and then tick that as well. And of course, make sure that the component is actually added to the camera blueprint itself. If it's not added, it's not going to work because it's just not there. So make sure you add that. At any rate, with those steps complete and with the camera variable correctly exposed in sequencer as a track, you should be able to add the focus actor track to the camera, select your target, and then instantly see that depth of field is updating because it's ticking. And again, it's totally possible to keep improving this system. You can add things like focus offsets and tracking speed if you want to change focus between one actor to another and other features. So, once again, I want to highlight that all that we've added here is essentially one track, so it's very artist friendly, and all the heavy lifting is done under the hood, invisible to the artist. Okay, so recap and conclusion. I wanna recap kind of what we talked about. We're here talking about efficient content creation in Unreal Engine. So we talked about how you can create a high quality and well-maintained animation library of base and additive and custom animations. You can create cinematic blueprints to contain cinematic friendly logic and systems to augment the library and save steps. And these made for gameplay systems, like blend masks and IK and all this stuff, these systems can be reused for cinematic purposes. It's not just about the library or any of these individual tools, but it's all of these approaches and workflows and systems combined to allow for efficient cinematic content creation in Unreal Engine, just like saving steps, making people work like faster. It's just awesome. Next, I know we covered a lot of systems and tools in this talk, so I would like to share links to Epic's documentation for these tools. I actually wrote most of these during my time at Epic, so if you've enjoyed the information provided here today, then hopefully these documents are equally as useful. And lastly, a bit of shameless plug for the company I work for, but I would like to offer our services for anyone looking to build a cinematic project in Unreal, whether it's for a game or a pre-rendered or a runtime experience. We offer deep Unreal Engine understanding for cinematics, as well as traditional cinematic integration services. We strive to provide artist-friendly tools and systems to build things correctly the Epic Games way, and we can scale for any project size. So thank you very much for your time and attention. I'm happy to answer any questions. Thank you again.